The Cray YMP C90, designed to be the world's most powerful supercomputer. Powerful, measured in speed, with peak performance 6 times that of the original Cray YMP8. Powerful, measured in compatibility, a new top end for the Cray Research Systems solution of hardware, software, applications, and networking. Powerful, measured in higher reliability and easier maintainability. Powerful, measured in a significant improvement in price performance. To bring this system to you, the people of Cray Research have pushed the limits of technology in every phase of development and manufacture. One of the first challenges designers set for themselves was to dramatically increase throughput using a dual vector pipeline, while still maintaining the vector processing performance customers expect from Cray Research.
The challenge with the dual pipes is to get the data in and out of the registers and then through the functional units, back through the registers and back to memory, and to sustain that bandwidth.
The new architecture was first verified on a Cray YMP using simulation software. In fact, the YMP was used extensively during development to shorten development time and test literally millions of options, long before the first hardware was assembled.
We use the Cray in a number of different ways. We use it to generate a lot of the files that we use to build and verify both the printed circuit boards and the ICs. We use it to support the whole build process. We use it to verify our designs are correct, both from a logical and from a functional point of view.
The chip went from 2,500 gate arrays to 10,000, a 4-fold increase in approximately the same space. Every dimension became tighter. Every feature tolerance became more critical. In the midst of design work, a new challenge appeared. A problem with the power busing on the chip. The solution seemed fairly straightforward to the Cray IC designers.
So they came to us, the processing group, and said, we've got a fairly simple fix. All you really need to do is just add a 4th level of metal to your 3-level metal structure. And it sounds fairly straightforward, but at the time I don't believe there was anyone producing a 4-level metal process for the outside world. It's the frontier of technology. No one understands the challenges with topography and what we're going to hit when we get there.
Because the designers couldn't afford to wait, the IC lab at Cray Research took on the task of developing the new process.
We gave it our best shot, and in 6 weeks we had working 4-level metal parts out. And it's a process that we transferred to Motorola after we developed it here. And at that time, it was 2 years ago, we don't know of anyone that was producing 4-level metal parts in production. Certainly not for building machines of our caliber.
The requirements for the ceramic package that holds the chip presented another set of opportunities to push the technology. For performance and reliability reasons, the ceramic package required more than double the number of pinouts, smaller leads, and very tight tolerances in a hermetic package. There was only one obstacle.
Nothing existed in the industry to do that. We had to invent absolutely everything. Knowing today what I know about it, it seems like it's impossible. All of the iron milling and metallurgical concerns, all of the sales to the various groups and the coordinating to get them to accept the dimensions, there were a lot of places that it could have fallen apart.
We learned in the last 3 years how to do a lot of things that no one had done before. Basically, we melded semiconductor, ceramic, and packaging technologies into one mesh to be able to form this package. If you went to a ceramic vendor, they do not have the technology of the thin films that are needed to be able to do this. The semiconductor people do not have the ceramic background that they could deal with the topography that is needed. And the packaging people are used to the thick film approach and wouldn't have the slightest idea where to start. It's been an incredible learning experience, and I think it's a very valuable package to the industry in general, not just Cray Research, but I think it will be a driving force for the packaging technology of the future.
The YMP C90's performance criteria affected manufacturing as well, including finding new ways to attach the package to the board. Bonding technology was adapted from the integrated circuit industry to ensure the highest product reliability.
When I first started with C90, one of the major challenges that we faced was the bonding technology. It was a company decision that we will go to a gold-gold interconnect on the C90. And the only way to do that is to use the IC world's technology of bonding.
No one had ever used this approach before on the outside of an integrated circuit to attach the package to the board.
In the C90, when you take that to the outside world and the geometries are bigger, the equipment doesn't exist, it's not just the different technologies in the bonding that we're doing, it's the equipment also.
The CPU and memory modules incorporate another innovation, flex circuits and edge connectors, specially designed for the YMP C90. Once again, engineers employed a technology in ways it had never been pushed before.
Because of the gold-to-gold bonding, we needed to develop flex circuits that were very clean, very small geometries, but we had to have a soft gold on these flex circuits, and so the handling characteristics of the flex circuits, the different vendors that we worked with on flex circuits, this was totally new to them.
From the beginning, the PC board designers knew they would be forging new ground. Each of the 22 layers would need to be optimized for function and performance. The unique fabrication process required new thinking.
We first found out that what we have done in the past, the stuff with the previous product lines, would not work. It just would not work at all. As that package gets tighter and tighter, so do all of our features. You know, the holes get closer together, the lines get closer together, more layers. And as that happens, it gets just about impossible for, in many cases, the person to, let's say, do repair work on these sort of things. It's come down to where it's either right the first time or it's no good anymore.
Today's Cray YMP C90 sets new standards as the world's most powerful supercomputer. New standards in speed, compatibility, price performance, reliability, and maintainability. To achieve these objectives required engineering innovation on an extraordinary scale in every phase of product design, development, and manufacturing.
I would say there's probably not one area in our facility that was not pushed. I can start right from the beginning of the process. You know, just I mentioned handling the materials. The imaging process, even today, is very challenging to control the tolerances that we have. We literally pushed, I would say in most areas, our process right to the edge.
The YMP C90, from the people of Cray Research, a supercomputing tool of exceptional power and capability.